Continuous probability distribution. A continuous random variable, if you remember, is a variable that can assume or take any value on a continuum, meaning it can assume an uncountable number of values. Let's see some example here. For example, thickness of an item, right? So it is a continuum. It can be any value. It can be 3.55669 infinity, right? Or the time required to complete a task, that's also continuous. Or the temperature, the weight, the height, and things like this, the qualities like this, characteristics like this, that they can quantify them in a continuous way. These are all examples of characteristics that can be used in a continuous random variable. Probability density function is the mathematical function defining the distribution of a continuous random variable, also called as the probability distribution function. Normal distribution. Normal distribution is the most popular and most important distribution in statistics. It is also called the Gaussian distribution. Normal distribution is popular and important because it often occurs around us. Characteristics such as heights, IQ scores, errors, and etc. In certain scenarios, they can actually be following a normal distribution. Also, normal distribution can be used to approximate other distribution. Even the discrete distribution like binomial distribution in certain situations can be approximated using normal distribution. Normal distribution is useful in problems that involve large amount of data. Now let's take a look at the shape of the normal distribution. As you see here, we have the random variable x here on the x-axis, and we have the probability density function f of x on the y-axis here. And in the middle, we have the average, the expected value mu. As you notice here, this shape of normal distribution is bell-shaped. You can actually see that we can approximate this by, for example, to help your imagination, this would look like a bell. So it's bell-shaped, and also it is symmetric, as you see here. So this part is the mirror of this part, right? On the left and the right, they are mirror and symmetrical. Also, the mean, the median, and the mode are all equal. So this is the median, or the expected value, and also it is the mode, because this is the most frequent part that you see here. Also, this is the median, because this is half of the data and half of the data are here. So for this distribution, we have mean equal to median equal to mode. The location here is determined by the average or the expected value mu, and the spread or dispersion of the data, or a scale of parameters, the parameter scale, is determined by the standard deviation sigma. The random variable in normal distribution can go from negative infinity, can take any value between negative infinity to positive infinity. So if you have a random variable x that follows a normal distribution, we would write it like this. We'd say random variable x would follow a normal distribution with average of mu and a standard deviation of sigma. So we write these two parameters in the parentheses, okay, like this. Let's now take a look at the normal distribution density function, f of x here. The formula for the normal probability density function is here. In this formula, as you see, this is a pretty complicated and complex formula. Here, E is the Neperian, or the natural number, the mathematical constant that approximately is 2.7 1828. This is of course pi, the mathematical constant of 3.14. And then we have sigma. We have sigma here. This is the standard deviation. X is the random variable. And we have mu, which is the average here. Properties of normal distribution. What can we say about the distribution of values around the mean in any normal distribution? 68% of data in a normal distribution is going to be within one standard deviation away from the mean on the left and right. So this would cover this one standard deviation on the left, one standard deviation on the right. This would cover 68% of data in a normal distribution, 68%. More 95% of data would be within two standard deviation away from mean, and 99.7% of data would be within three standard deviation away from the mean, as we see here. So these rules would apply especially for normal distribution or any distribution that its shape would look like a bell-shaped symmetrical that we have in normal distribution. Standardizing a normal distribution. Any normal distribution with an average of mu and a standard deviation of sigma can be transformed to a standardized normal distribution or a z distribution with average of 0 and a standard deviation of 1. This process is called a standardization of normal distribution. Let's see how this transformation works. So if we have a normal distribution, suppose x is a random variable that follows a normal distribution with an average of mu and a standard deviation of sigma. If we take the z-score of x, which is equal to x minus the average divided by standard deviation, then z of x would actually follow a standardized normal distribution. That means a normal distribution with an average of 0 and a standard deviation of 1. So if you find the z-score of random variable x, the z values for all the x's would follow a standardized normal distribution. That's why it's called a z distribution. But what does the z value tell us? The z value would tell us how much x actually is away from the mean in terms of a standard deviation. How many standard deviation x is away from the average? A standard normal distribution, or some call it z distribution. It's actually a normal distribution with an average of 0 and a standard deviation of 1. So it's a standardized version of normal distribution. But the shape of it and a lot of characteristics is the same. As we see here, the average is in the middle, which is also the mode and the median, and the standard deviation is 1. And the shape of it is still bell-shaped and symmetrical. Values above the mean would be positive, and below the mean, the mean on the left, would be negative values because the average is 0 here. Let's see an example. If x is distributed normally with an average of 100 and standard deviation of 50, the z value for x equal to 200 is what? So here we have x following a normal distribution with an average of 100 and a standard deviation of 50. We want to find the z-score or z value of 200. So that's equal to 200 minus the average, which is 100, divided by standard deviation. So that would be equal to 2. This means that 200 is 2 standard deviation away from the mean.